Hi, this is the video on Pure Chemistry 2010 to 2019 TYS Topical for the Periodic Table chapter. So as I go through the questions, please write down the annotations. Whatever that I write down, you write down on your TYS as well. Okay, so it's very important for us to have the habit of annotating the questions as we are doing it. Okay, so for the first question, this is 2010. So if let's say you don't have the same version of TYS with me, as me, then you have to follow the O-level year of the question. Okay, so this is 2010, question 6, paper 1. Okay, element X and Y have proton number 3 and 11 respectively. Both elements react with water to liberate. Liberate means to release. Okay, liberate means release hydrogen gas. So first thing is you have to annotate proton number 3, that means electronic configuration 2.1, and this one would be 2.8.1. So this is lithium and this is sodium. Okay, reacts with water. So which statement about X and Y is not correct? So both are group 1. So group 1 metals of course react with water to form hydroxide as well as hydrogen gas. So which statement about X and Y is not correct? The chlorides of X and Y are molecular. Chloride of X, which means that lithium chloride. Chloride of Y, which means sodium chloride. They are definitely not molecular because they are ionic, metal and non-metal. So the answer is A. So if you look at the rest of the options, now remember in doing MCQ questions, not only you have to find out the answer, okay, also you have to look at other options, see why they are not, why they are correct. Okay, so this is how you maximize your learning by doing the MCQ question. X and Y are in the same group of the periodic table, definitely, because lithium and sodium are in the same group, which is group 1. X and Y both form basic oxide. Now what is basic oxide? Basic oxide is actually metal oxide. Okay, metal oxide except the zinc oxide, aluminum oxide and lead 2 oxide. Those are amphoteric oxide. Okay, so basic oxide are basically metal oxide. That means they react with acid to form salt and water. So Y is more reactive with water than X. Y is more reactive. Definitely sodium is more reactive than lithium. Okay, question number 2. Each of the halogens, this one was added, X2, Y2 and Z2 was added to samples of aqueous solutions containing the ions of the other 2 halogens. Okay, the table shows the results. So you have halogen X2, Y2, Z2, and it says it was added to samples of aqueous solution containing the ions of the other 2 halogen, which means that this would be the aqueous solution containing the ions of X, Y, and Z. So what would be the aqueous solution that contains ion of X? So an example would be actually this one is wrong. These are the halogen, right? Yeah. So an example of aqueous solution that contains, let's say for example, chlorine. Okay, that would be NaX. Okay, so this one, the aqueous solution would be, for example, NaX. This one, an example, NaY. This one would be an example, NaZ. So an example X, if let's say X is chlorine, right? So this one will be sodium chloride. This one, an example, if Y is iodide, this one will be sodium iodide. And if let's say Z is bromide, is bromine, then this one will be sodium bromide, the aqueous solution. Aqueous solution containing the ions of the other 2 halogen. So you can actually make this as sodium salt. Okay, so if I have X2 and then Y, okay, X2 add to NaY, Okay, X2, this halogen, add to NaY, aqueous solution of Y. Okay, and then you get a Y2 displaced, which means that whichever that gets displaced is the less reactive. So in this case, we can conclude that X is more reactive than Y. So same thing over here, X is more reactive than Z. Okay, so which means that X is the most reactive. That's why if you look at the options, X is the most reactive. It's either A or B. Either A or B. Then you look at further. See, Y2, no reaction. That means, so this one, what will be the conclusion? The conclusion is your X is more reactive than Y. Because a wire cannot be displaced. You cannot kick out. I mean, X is not displaced. That means you cannot kick out the X. Which means that X is more reactive than Y. Likewise, over here, this one, no reaction. That means Z is more reactive than Y. So from here, the conclusion is what? From here, the conclusion is Y is the least reactive. So Y is the least reactive. That's why the answer is B. No need to look at Z already. Okay? Yeah. So the very important thing is aqueous solution containing the ions of the other two halogen. What do you mean by aqueous solution? Aqueous solution, that means a halide solution. That means a solution that contains halogen. An example, sodium chloride or potassium chloride, or if you want magnesium chloride can also. Once you have written down the chemical formula of the aqueous solution, then it's very easy to see which halogen gets displaced by what. Okay, that's for number 2. Okay, number 3, which substance reacts with water to form a soluble compound and an insoluble gas? Soluble compound reacts with water. Okay, so this one is 2010, question 23. Okay, just now was question 22. Okay, so this one react with water. Only the group 1 metals, the alkali metals, react with water to form a soluble compound, which is alkali, as well as insoluble gas, which is hydrogen. So this one would be alkali in this case. So it's cesium. Cesium is group 1. Ammonium sulfate with water, there is no reaction. Calcium carbonate with water, no. Calcium carbonate doesn't react with water. Calcium carbonate undergo a thermal decomposition. And copper doesn't react with water. So this one, excuse me, the answer is cesium. It's group 1 metals, alkali metals. Okay, let's look at number 4. X, Y, and Z are in the same period. What's the meaning of same period? Same period means the horizontal period, not the vertical group. Same period. So same period means same number of. So X, Y, and Z, they have the same number of what? They have the same number of electron shell. Same number of electron shells, okay? Okay, that is the same period. Same number of electron shell. Okay, X is a non-metal, Y is a metal. Z shows the properties of both metals and non-metals. What is the order of these 3 elements across the periodic table? Now you have a metal, you have non-metal. This one, metal and non-metal. So what is this? This is actually the metalloid. Metalloid. Okay, this is actually the metalloid. The metalloids are basically the elements at the border. Okay, at the border of the staircase. So what is the order of these 3 elements? So it's very simple. So these are the metalloid. So you can look at your periodic table. Okay, this is the staircase. Right below, right in between boron and aluminium would be the staircase. Yeah. So these are the metalloid. Metalloid is right at the border. So you have metal, you have metalloid, you have non-metal. Okay. So that's why they are metal, okay, which is Y. Z is a metalloid, and the non-metal, the X, Okay, don't have this amphoteric. Okay, so metals, properties of metals and non-metal, these are the metalloid. Okay, let's look at the next question, 2010 again, question 31. Okay, number 5. Which element has the greatest number of electrons in the outermost shell? Okay, in the outermost shell. Okay, let's see, I think... okay, at the outermost shell of its atoms. Okay, so this one, greatest number of electrons at the outermost shell. So you have to write down the electronic configuration. Look at the periodic table, write down the electronic configuration. Then after that, you just look at the valence electron. Which one has the greatest number of electrons, greatest number of valence electron? So obviously it is A. Okay, number 6. Which statement about the alkali metals is correct? So alkali metals are the group 1. Okay, alkali metals are the group 1 metals. Their melting point decrease on descending the group. Okay, descending means going down the group. This one means go down the group. Okay, as you go down the group, melting point decreases. So this one, it's about the trends of the group 1 metals. Okay, so the trends, if you look at the mind map, okay, the trends are clearly written here. So if you look at the alkali metals, the group trends go down the group, melting boiling point decreases, density generally increases, reactivity increases. So these are the trends. So if you look at the other options, right, reactivity decreases on descending, cannot be reactivity increases. Like for example, rubidium is more reactive than potassium. Okay, they form covalent bonds with the halogens, cannot be, because halogens are the non-metal. And the group 1 metals are the metal. Metal and non-metal are ionic. They form oxides on reacting with water. They don't form oxide. They form what? They form hydroxide. Okay, remember the group 1 metals? The alkali metals, when they react with water, they form alkali. Like for example, sodium reacts with water to form sodium hydroxide. So an example, sodium, water, you get sodium hydroxide, which is a hydroxide plus hydrogen. Okay, so this one is a hydroxide, it's an alkali. Okay, number 7, across a period, there is a trend from metallic to non-metallic elements. Okay, so this one is similar to this. Okay, this is caused by an increase in the number of valency electron. That means valence electron. So metallic to non-metallic. Let's say group 1 to group 7. Group 1 means 1 valence electron. Group 7 means 7 valence electron. Then of course, the number of valence electron increases. Metallic to non-metallic properties. Because metallic, if you look at the definition, what's the meaning of metallic properties? Metallic property means how easy the metal lose the valence electron to form positive ion. So as there are more and more valence electron, right, then it's becoming harder and harder for it to lose the valence electron to form a positive ion. So that's why the metallic property decreases. So metallic and non-metallic properties is affected by the number of valence electron. The fewer the number of valence electron, the more metallic the element is. The more the number of valence electron, the more non-metallic the element is. Okay, so this one definition of metallic and non-metallic. Very easy to lose valence electron to form positive ion. That means very few valence electron. Because only when very few valence electron, then you can lose the valence electron to form positive ion. Non-metallic would be very easy to gain electron to form negative ion. So the more valence electron you have, the easier it is to gain electron to form negative ion. Just like 7 valence electron and 6 valence electron. Which one is easier to gain electron to form a negative ion? Obviously is 7 valence electron. That's why group 7 more non-metallic than group 6. Okay, over here number 8. So this one is 2012 question. Okay, question I think is 25, right? Chapter 8. Yeah, it's question 25. Okay, excess chlorine gas can be tested with damp blue litmus paper and bubbling the gas through the potassium iodide solution. So write down the chemical equation. Okay, when you bubble chlorine gas through potassium iodide. So again, this is halogen displacement. You have two halogen, so you have to ask yourself which halogen is more reactive. Chlorine is more reactive than iodine, so chlorine will displace the iodine out to form iodine solution as well as potassium chloride. What color would the damp red litmus paper and potassium iodide solution be at the end? At the end of what? At the end of the test with excess chlorine. So if you look at the Ki, okay, so this one is colorless. This one is colorless. This one is iodine solution. It is brown. Okay, then red litmus paper, chlorine. So this one is from your salt chapter. How do you test for chlorine gas? You have to use a blue, moist blue litmus paper, and then it would turn red and then bleached and then become white. Yeah, so it's either A or B. Then the potassium iodide solution, what will be the color? The color at the end will be brown. Okay, colorless to brown. That's why the answer is A. Okay, number 9. Which statement describes the changes in the elements from left to right across a period of the periodic table? Left to right, this one is quite straightforward. The elements change from metals to non-metals. Ability to conduct electricity increases. Cannot be. Metal to non-metal. Metal conduct electricity easier. Number of neutrons in an atom decreases. No. Number of protons in an atom decreases. No. Actually, in fact, protons should increase. Okay. Number 10. The diagram shows an experiment involving halogens and aqueous halide ions. Halide. Okay, that means a solution that contains halogen. Halide ions, that means a halogen ion. So which choices of Y2 and X minus give the result? So this one have to be, it's a thinking question, so have to think carefully. You add halogen Y2, solution containing halide ion, X minus. So for example, this one will be NaX. It's a solution containing the halide ion, so NaX. For example, then after that, solution containing halogen X2 and halide ions Y minus. See, halogen X2, which means that this X has been displaced by who? By Y. X has been displaced by Y, so that means Y is more reactive than X. So this would be the conclusion here. So this one basically means that you get I2 plus NaY. So NaX plus Y2 then become X2 plus NaY, which means that Y is more reactive than X. Okay, so which choices would give the result? So Y is more reactive than X. Okay, Y is more reactive than X. So this is Y, right? Y more reactive than X. Wrong. How can iodine be more reactive than bromine? Bromine is above iodine in group 7, so bromine is more reactive. So Y more reactive than X. Is chlorine more reactive than bromine? Yes. Chlorine more reactive than iodine? Yes. So that means no, yes, yes, no, yes, yes. So the answer is D. Okay. So you got to match. So this is a very important conclusion. Okay, you have to match Y and X. Match, match, match. All right. So this is a thinking question. So remember, when you see this kind of thing, a solution containing halide ion, just imagine that it is NaX. It's easier for you to see the displacement. NaX to become X2 plus NaY. So Y is more reactive than X. Okay, next question 11. The symbol of an atom of element J. Okay, I have to stop here. It's 20 minutes because if the file gets too big, it may have problem uploading. So I have to record another video.